So far, we've talked about shortcuts for finding derivatives using the power rule, the constant rule, the product rule, and the quotient rule. And those are all very good for polynomial functions. But we're going to add to that today the derivatives of our trig functions. Now, these are rules that you're going to want to memorize, just like the power rule, the quotient rule, the product rule. But before we memorize them, I am going to go through the proof of a couple of them. I'm going to prove this one and the tangent one. I'm not going to go through all of them because honestly, the proof of how we got to the derivative is not all that important for you to know. But I don't want you to think that they're just, floating out there for no reason. So I'm going to show you really quick sort of quick, how to do the derivative for sine and then the tangent, which is much easier. So let's start off with the derivative for sine. I'm just going to put it down here. So if I have f of x equals sine x, and I want to find f prime of x, I'm going to go back to my limit definition. So remember our old limit definition, limit as delta x approaches 0 of f of x plus delta x, so in this case that would be sine of x plus delta x, minus f of x, in this case that's sine x, all over delta x. Now that may look like it's kind of already to a point where we can't do anything, but remember last year we did do some sum of sine and cosine. So I put them up on the board. I don't know if you guys remember, but anyway, here it is in this book, the sine of alpha plus beta. It's sine alpha cosine beta plus cosine alpha sine beta. Sine cosine plus cosine sine. So we're going to use that rule to spread this out a little bit. So we're going to have the limit as delta x approaches 0 of sine x cosine of delta x plus cosine of x sine of delta x minus sine x all over delta x. Okay. So it doesn't look any better yet, but here's what we're going to do now. We're going to make a few changes to the order that we have. I'm going to move this minus sine x over here with this first term, and this cosine x sine delta x over to the right. So we're going to have the limit, all I'm doing is rearranging. As delta x approaches 0 of sine x cosine of delta x minus sine x plus, oh my goodness, my dogs are going crazy. All right, so sine x cosine x minus sine x plus cosine x sine of delta x all over delta x. All right, so the only reason I did that is so that I can now separate these out. So I'm going to create two fractions here, sine x and cosine of delta x minus sine x over delta x plus cosine x sine of delta x over delta x. All right, so all I did here was switch this and this, these two things, and then I split this up into two fractions because when I add fractions, they have a common denominator, so I just pulled them back apart. All right, so let's get to the point of why I would have pulled them back apart. So I have the limit as delta x approaches 0. And here I can factor out the sine x in the numerator and have cosine of delta x minus 1 over delta x. And over here, I've got plus cosine x times sine of delta x over delta x. So these things should look kind of familiar, that and that. Remember that those are a couple of things we were supposed to memorize. This one is just 0, and this one is 1. So now I've got the limit as delta x approaches 0 of sine x times 0 plus cosine x times 1. And so this part is just 0, and I just get cosine x. So all of that to say that the derivative for sine x is cosine x. The derivative for sine x, we get cosine x. Now, like I said, I'm just going to tell you most of the rest of these. So we have this one, derivative of sine x is cosine x. The derivative of cosine is going to be negative sine x, and you can derive it in almost the same way that we just did sine. For tangent, though, I'm going to show you the proof very quickly. So let's move down here again. I'm going to do it down below here. So if I want to do the function is tangent x and find the derivative, I know that tangent is equivalent to sine x over cosine x. And you guys know your quotient rule, right? And I just gave you the derivatives for sine and cosine. So here we go. We're going to use the quotient rule. We have the bottom, or the low, times the derivative of the high. And the derivative of sine is cosine. Then minus the top, or the high, times the derivative of the low. And the derivative of cosine is negative sine. All over the low squared. So we have cosine squared x plus sine squared x over cosine squared x. And sine squared plus cosine squared is just 1. So we have 1 over cosine squared x, and 1 over cosine squared is secant squared. So the derivative of tangent is secant squared. All right, so let's fill the rest of these in. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Oops, cosecant squared x. The derivative of secant is secant x tangent x, and the derivative of cosecant x is negative cosecant x cotangent x. So memorize. The more you use them, the better off you'll be. So you need to start memorizing now. All right, so let's see how this is going to work, because we need to know these derivatives, but we can't forget that we also have the product, the quotient, all those other rules too. So here's how this is going to work. Look at our first example. These two functions are multiplied together. That means we're going to need to use the product rule. So the product rule, we have the first function times the derivative of the second. The derivative of cosine is negative sine, plus the second times the derivative of the first function. And the derivative of x squared is 2x. So we end up with negative x squared sine x plus 2x cosine x. Now you could factor out an x, but at this point we don't really have to do that. We're not doing anything with it, the function just yet. So that would be fine. All right, in our second example here, looks like we need to use the quotient rule. So if you need to look it up, go ahead and look it up, but we're going to have to use the quotient rule, low d high, high d low, over low squared. So here we go. We have the low times the derivative of the high. The derivative of secant is secant x tangent x. Oh, I'm going to run out of room. Minus, I think I'm going to move this over. Actually, let me just rewrite it so I can scoot it over. 1 plus tangent x, secant x, tangent x, minus, okay, I just rewrote it. All right. So we have the low derivative of the high minus the high times the derivative of the bottom, the low. And so the 1 is just going to be 0, and the derivative of tangent is secant squared. All over the bottom, squared. All right. So we have, I'm going to need to distribute this. So secant x tangent x times 1 is just secant x tangent x. And then secant tangent times tangent would be plus secant x tangent squared x. And then minus, and then secant times secant squared is going to be secant cubed. All over 1 plus tangent x squared. And we'll leave it at that. All right, so now that we have our derivative rules for trig functions, then they can now ask us to write the equation of the tangent line whenever our functions involve trig. So we're going to write the equation of the tangent line for y equals cotangent x minus 2 cosecant x, where x is pi thirds. And then I'm going to talk about this normal line. We haven't talked about that yet. So let's go ahead and write the equation for our tangent line. So we know that x is pi thirds. We need to find y, the y value at pi thirds, and then we're going to find our slope at pi thirds. So for our y value, we're going to plug into this function. We're going to have cotangent of pi thirds minus 2 times cosecant of pi thirds. All right, so we probably need to look at our chart for pi thirds. Pi thirds is 60 degrees. And so at 60 degrees, we've got 1, 2, square root of 3. And so let me erase this m. We'll get to that in a minute. So we're going to plug that in here. Cotangent of pi thirds. Cotangent would be 1 over square root of 3. Remember, cotangent is x. I guess I should say that too. Cotangent is x over y. Remember our ratios. So x over y, 1 over square root of 3 minus 2 times, and then we have our cosecant, which is going to be 2 over the square root of 3. 2 over the square root of 3, r over y, cosecant, r over y, just in case we've forgotten. All right, so we have 1 over square root of 3 minus 4 over square root of 3, or negative 3 over square root of 3. Now, if you don't want to leave that in the denominator, in this case, it might be helpful. Just make it look better. But if you left it negative 3 over square root of 3, that's fine. But you can multiply by square root of 3 over square root of 3. That gives us negative 3 square root of 3 over 3, and the 3's divide out. So we get negative square root of 3. But remember, those are the same thing, so you could use either one. This one just happens to look a little cleaner. So now we have x, pi thirds, and y. negative square root of 3. Well, that's a lot of trig. You're going to have to remember some trig stuff. Okay, and now we need our slope. So to get our slope, we have to take our derivative. So we need the derivative of this equation. So y prime, remember the derivative of cotangent is negative cosecant squared. So negative cosecant squared x. And the derivative of cosecant is negative cosecant cotangent. So we're going to have minus 2 times negative cosecant x cotangent x. All right. So we have negative cosecant squared x, and then minus 2 times negative, so plus 2 cosecant x, cotangent x. All right, so now we've got to solve this one at pi thirds. So the derivative at pi thirds, negative cosecant of pi thirds, and then we're going to square it, plus 2 times cosecant of pi thirds times cotangent of pi thirds. Now we've already done these up here, so I think we can just pull them really quickly. So cosecant of pi thirds was up here, and we got 2 over square root of 3. So we're going to have negative 2 over square root of 3, and we got to square that, plus 2 times, oh, I wrote cosine. This is supposed to be cosecant. Cosecant of pi thirds. So again, we get 2 over square root of 3. And then cotangent of pi thirds, we got 1 over square root of 3. All right. So when I square this, negative 2 squared would be 4. Square root of 3 squared is 3. Plus, and then 2 times 2 is 4 times 1 is just 4. Square root of 3 times square root of 3 is just 3. So I have 4 thirds plus 4 thirds. And that is not right. So what did I do wrong here? Oh, way back up there. Okay, so way back up there. Whenever we took the derivative and we got negative cosecant squared x, this should have been negative cosecant squared. So negative cosecant squared. So this is actually a negative 4 thirds plus 4 thirds, which is 0. So we actually get out of all of that our slope is 0. So slope of 0, y value of negative square root of 3, x value of pi thirds. So our equation would be y minus the negative square root of 3, so plus square root of 3 equals 0 times x minus pi thirds. And since 0 times x minus pi thirds is just 0, we actually just end up with y equals negative square root of 3. Now this is probably not the best example to talk about the normal line, but the normal line is perpendicular to the tangent line. Well, perpendicular lines we do know about. So just back in algebra, if I have a slope of 2, then a line that's perpendicular to it would have a slope of negative 1 over 2. Remember, it's the reciprocal, and then you make it negative reciprocal. Flip it, change the sign. But our slope here was 0. And so 0 slope is a horizontal line, which means that the perpendicular line is a vertical line where the slope is not defined. So if this is our tangent line equation, then our normal line equation would have an undefined slope. So the undefined slope would just be the x value at that point, just going vertically. So x equals pi thirds. because this is the point at which we were finding our equation anyway. So x equals pi thirds is just an undefined slope, which would be perpendicular to a zero slope. All right, and then down below, just a few review questions. For these trig functions, don't forget when we're finding limits, the first thing we want to try is subbing it in. So 0 into sine x, sine of 0. Sine at 0 is just 0. For cosine, cosine of 0 is 1. And these are the ones we were supposed to memorize. The limit as x approaches 0 of sine x over x. We cannot direct sub, but we were supposed to memorize that one is just 1. And then the limit as x approaches 0 of cosine x minus 1 over x. Also, you cannot direct sub, but we're supposed to memorize that one is 0. So this is probably a good way to memorize. If you haven't already memorized these two, if you'll think about the fact that, for the sine one, we know that when I can sub in just a sine, I get 0. And so when it's over x, it's 1. And then this one, when I sub in for cosine 0, I get 1. When it's x on the bottom, I get 0. So maybe that's helpful.